today anyway. Today, yeah, let's just see, because I mean, then this week, upcoming week, I know you've already made a start. It's all about the stacking, the voting, the ensemble learning and whatnot, and the experimentation through that. I know you might not have anything ready because you're just starting it basically. But if any of you, wait, have you got anything to share? What you've done in the past week and whatnot?
Regarding the project, so I mentioned in the previous meeting that I was working on the dashboard.
Yeah,
So
that's right. Yeah.
today I had some time, so I also made a very basic dashboard for the project on Gradio. So
Oh,
Gradio
cool.
is, yeah. So
Can you
I
share that?
like,
You're all right to share
yeah,
that
yeah,
now?
yeah,
Yeah,
yeah, yeah.
spot on.
Let me just share the screen. You guys can see my screen?
Yep.
Yeah, so let me just run this. And I also have the Streamlit. So this one will take a little time to load. But this is the Gradio one. I haven't made too much progress in it. For now, we can just upload an image and it performs the pre-processing on the image, like reshapes it and resize it. And I have just the output is just an image for now. And this one is a bit more finished. So in this one, this is the Streamlit one. So in this one, when I upload an image, it pre-processes it so that it meets the VGG16 input shape requirements. And then it extracts features for that image, because these features will be then passed to our image classifier XGBoost, and then it classifies it. So 0 is for, I think, hem, and 1 is for all. I'm not sure about it, but yeah. So this is just a basic uh, overlay of the dashboard. So I still have to work on it, move things around to make it look more pleasing to the eyes. And
No, that's really good so far. Yeah,
yeah.
impressed.
So but I was thinking that uh, as we have just an image and there is not too much content for the dashboard, so in that case I was thinking that Gradio is much better, because the user interface and everything
Yeah,
is
it looks a bit
yeah,
more slick, doesn't it?
yeah. And there is still a lot of stuff that we can do with it. I haven't explored the Gradio too much.
Hmm.
This is I just made it half an hour, 40 minutes ago.
Yeah, yeah. No, that's really
Um,
good. It looks good. Yeah, it's and I've said it a million times. The dashboard isn't sort of a necessity for the project, but it'll be much better if we have a deployment for your sake in terms of your portfolio, and you can demonstrate it your work and maybe record a demo video, you know, and upload it to your YouTube channel, upload it to your LinkedIn, and just say that's what you've been working on. But yeah, it looks really good. And yeah, I would agree. The Gradio one looks a lot more, it looks a lot more slick and modern, doesn't it? So yeah, I like that.
yeah.
Yeah, that's really
Um,
good work.
yeah, and our team, if Somya and Damir wants to present their work, they can, but I will just show their results they have been working on. So Damir has been working on the feature selection, but he spent a lot of time on sorry, not feature selection. I think it's feature selection and hyperparameter tuning both. So he spent a lot of time on it, but the hyper parameters that he was able to find for the model are very good. And as you can see, without any voting classifier, implementing any voting classifier or anything, still the minority class is being the true predictions are pretty impressive,
Yeah.
considering the class imbalance and everything.
Yeah.
I
So
can
this is
share my
Damir's work.
notebook if you want.
Yeah, go on,
Yeah,
Damir. Go ahead.
let me stop my. Yeah.
Share. Just find first where I put it. Which window? So many windows open. Okay, yeah. So, can you see that?
Yep, we can see that.
Okay, let me go at the beginning. So this
Could
is
you maximize it? It's just that the text is a little bit small. Yeah, that's a bit better.
Better?
Yeah, that's fine.
Okay, or maybe I can also just do see now I have to move you. I have those pictures now. I'll move trying to move them. Oh, what am I? What's going on now? Is it better now, or I can maybe zoom a little?
No, it's fine. Yeah, it's fine now.
Okay, okay, so this is just the beginning, and first I did so I was doing with the pipeline, so that's why I started here. I just did the classifier in the pipeline because then I will be able to start. So this is the base. Nothing it's happening, right? Just the parameters and what we get here. I think 8495. It's accuracy, and these are those normalized and unnormalized confusion methods. So this is our base. So the first one I did the feature selection. So what I did here, I used this ANOVA key parameter as a hyperparameter. So that's why it's in the params here. And in this part, I started with just 100 and the maximum of the shape, maximum number of features, but I want to start with the 100, not because nothing probably will happen. These are some of these features, some parameters for executive boost, and I was looking for the F1 score. Yeah. And this, I was using 100 trials, and then we are getting some results here. So we see that we have, let's say, the best this like 2,300 something features. That was in this one, and so this is now just repeat the model. So we have these two things in the pipeline, select best and classifier, and then we get this result. In the next time, I did few changes. I was looking just to find where it's mostly looking for the max depth and I think number of estimators. And another thing that I changed, I said, okay, let me try to use more trials. So I put 200, and the best result we got in 108 trials. So it's just, you know, sometimes you have to be a little bit lucky or not. If I just go with the 100, I will miss this the best. So it's just hard, and I'm just trying to figure out. You can see here. If you go to 108, as you can see, trying to figure out, so 108 here, and it was 921 for F1 score on this one. But all others are close, 9-1, you know, but this one just jumped here. And nothing else happened after that. So when we look the results, we got the accuracy 87.35 with this one, and this is the matrix, confusion matrix. So it looks pretty good. But then next time I was playing with also cross validation. That took a long time, and results are not so good. So I didn't put that. I deleted that. But then here I decided to go with the scaling. Not sure if that made the impact, but I said, okay, let's put one pre-processing part here. So we did the scaler in the pipeline, ANOVA, and classify. I think, well, that I did one more change for the choosing the best this number of features. So I just started to say, okay, let me just do first 20%, start with the 20% of number of features, like a starting range, go to the end, but in the 10 steps, so that it doesn't have a online. I don't know how much can they make better or not, but not only once, but just 10 steps going through this. So that was the change comparing before and the scaling. And so I did 120 just to see if I catch up this, maybe 108 or whatever, you know. Didn't want to go too much, too many trials. And then we can see here that this time the number of features was a little bit higher, 4,000 and more, almost all of them. But here we then refit it, and we got a little bit lower than the best accuracy that I had, 8712. But we can see that here we got the recall a little bit better. We can do 0.71. And so this, and then I tried to do pruning, and I was playing several days with this. It's a tricky part because of pipeline. Pipeline makes much difficult, and I don't have so much experience about pruning, so I was playing them yesterday. I practically separated pipeline in 2 pieces so that I can get this part here, test that I need for pruning. So practically I did that. So you have here I had to fit only on the first part of the pipeline, and then got this test FS, and then I was doing the second part of the pipeline, fitting to that, and doing this, and then I was doing prediction on the whole part. Now I don't know if this is correct or not, but I was trying to get something working yesterday night. And then the problem is here. It seems that the pruning is taking a lot of memory. I was checking first time it failed on the 24th trial, and then I was starting checking the resources on the call-up, and it's practically coming to, let's say, 11. In this, now I have only 15 gigabytes memory for the GPU, and it comes to 11, 12 gig, and then it just failed with the output memory. It failed on, I think, 27. 27, so I had only 26, so I recreated from the output, I recreated the parameters on the 26 on the best one, and the best one was I think 24. So I recreated that, or 26. Maybe maybe it was 26. The best one was maybe 24. I made a mistake here. So anyway, I copied those parameters and put them in refitting. So here I didn't do scaling. It was just and what I did here, we have a little lower a little bit, but it was only 26 trials. I couldn't go further. So we got 86, 68, and you know, this a little bit failed. But I don't know what will happen if I was able to run all 100. Can pruning can improve that or not? It's hard to say because it seems that it takes a lot of time. And
Yeah.
then here I just make all this comparison, and I think those two looks like the best. These two. So
Cool.
it's number 2 and 1 that I use scaling.
Yeah. In terms of the pruning, if you're running out of memory in Google Colab, shift it over to Kaggle. They've got better GPUs and more memory.
I was trying to do that. Then it took me some time to figure out how to transfer to Kaggle. I got that notebook. I wanted to start. Then I couldn't load the data set because the pickle that is used for those data sets, it's not in the Kaggle. Then I realized, okay, I need to update pandas. No, I cannot update pandas in Kaggle because Kaggle is in 3.7 Python. So now I start there. So at that moment, I got back some resources on the Colab. So nothing is perfect, you know. Wherever you go, you face some other issue, you know.
Yeah.
So anyway, this is like so this one is the pruning that's unfinished. So we don't know what will happen here, but these two were relatively okay. So I don't know if you can get better, but it's just a you know game of numbers. If you just come at the point like this one, I was lucky that I said let's go to 100 or 200 because 100 that I usually done, I wouldn't get this result because the best trial was 108. So you don't know that where will be the best result. Maybe the after 200 we will have a little bit more better, but you can just kind of go like that. Whatever.
Yeah, that's it. It's when you call it's good enough. Do you know what I mean? Because you know you could sit there and put 1,000 trials in, but yeah.
And for these two, I did this course, sub course. So this is just for a training on the left side, and then on the right side we have a. So this one is this first, and then this one is that with the 200 trials, and this one is that with the scale. So then this is what I practically finished yesterday.
No, that's really good. You've done really good work there, and it's it's all about the experimentation, and I think you've handled that quite well. It's just it can be frustrating when you run out of computing resources, especially on computer vision tasks as well. But yeah, I'll see if I can. Because have you uploaded this notebook to the GitHub?
No, I'll do this today. This is just now in a Colab. The link is on Slack, you know. But
cool.
I will do this because I finished yesterday around midnight. You know this.
Yeah. Okay. So what I'll do, I'll upload. I'll see if I can get it running in Kaggle, and I'll do that pruning experiment specifically.
Yeah, and I'm not sure really if I set up everything correctly for a prune. I was also trying to eliminate those output for this validation, but I didn't know how because it's just a lot of them are practically you are getting for each tree that you are doing.
Yeah.
Remember? Yeah. And except if it prune them, then you have a less, right? but that I didn't know how to eliminate because it just takes a lot of space and so that, and as I said, so what was the problem here? When you have ANOVA, you get the result. I think it does automatically extrain, change the features, number of features of extrain. It doesn't touch X test.
Yeah.
But when you are doing here as a pruning, you have to put the evaluation set. And when you put X test, now that's the original number of features. And I was getting error because it's comparing less number of features X train with this original number on X test, and you couldn't go further. So that's why I separated here 5, you know. So I don't know if that's correct way to do or not. This is, you know, I couldn't find, you know, but that I was working several days on that part. And,
yeah. I mean, intuitively, that sounds like you've done the right thing there. But I'd have to check the outputs and whatnot. But yeah, if you upload that up to GitHub, I'll take a look and I'll see if I can transfer it to Kaggle, and I'll go through it and see if there's anything, you know, if it has been implemented correctly. But off the top of my head, that does sound like it. Yeah, it would work. But yeah, I'll peer review it, as they say.
Okay,
cool.
I'll do this soon after we finish. Okay.
Cool. Yeah, that's really good work. Very impressed. Has anyone got any? Go on, sorry.
Yeah, I just want to say, I think I wanted to put this K, I know a K in a hyperparameter because it's just I was a little bit behind Wallace, and always they were talking how many, what percentage, but it was just a guessing. Okay, let's start 40, 30. So, and then I noticed in that article that from the SML Mastery, he was doing this in a grid search. So he was practically putting ANOVA with the classifier to grid search. So I said, why we couldn't put this in a tuna, right? And that's why I got this idea, and because it's really hard, as you could see. Sometimes we got the best result with the 4,000 features, and sometimes with 2,000 something. So it's really hard to, you know, go with like just like percentage or something.
Cool.
So I'll stop sharing now.
Yeah, cool. No, that's great stuff. Yeah, I was just gonna answer the question in the chat there. Always beat me to it. Yeah, it's the best K value will change. And that's just simply because the models work in different ways and have certain strengths and weaknesses. So yeah, it wouldn't be the same K value throughout. It's just one of them. That's the thing. It's a lot of the time. Yeah, you know, you could be the best machine learning engineer in the world, but sometimes it can be just black magic and luck that your experiments pay off. You know, it's great having an understanding and stuff, but it is quite you know, it's an iterative process, and it is subject to what's the word, randomness, shall we say. So yeah, it would shift if you use a different estimator. But yeah, that's the fun of the experiments, and that's why we need to do experiments. And you know, Damir has showed a fantastic notebook with a good set of experiments, and he has seen a real improvement as he's gone on throughout that. So yeah, very impressed, very good work. Has anyone got anything else that they'd like to share or talk about at all? We've got 4.5 minutes left. Feel free.
I have just a small suggestion for Soumya. He has been working on the voting classifier.
Yeah.
And he, in his voting classifier, let me just double check, but he used random forest, XGB, and logistic regression. So I was just trying to, I'm just suggesting Soumya that if you could use a different classifier instead of random forest, because XGB and random forest are both tree based. classifiers. And I think Rach has mentioned it already once in the meetings that it's good to use classifiers that have like different mathematical approach towards the predictions. So I would say instead of random forest, try using SVM, or not even SVM. I would say naive base would be much better, because it's a probability based estimator, and XGB is tree based, and logistic regression is linear estimator. So it would be like a good mix of three different kinds of estimators.
Yeah, it's not a completely strict rule. I've seen it in the past where you can combine similar algorithms, but it's a good idea to try and balance the pros and cons of each of the stacked classifiers or algorithms. And yeah, so yeah, you know, the basic sort of premise of stacking them is that you've got like a level 0 models which will combine all their predictions. So that's why the idea of having ones that work in different ways might strengthen the prediction. Not always true, but it's usually, you know, 90% of the time that's the way it happens. And then your level 1 algorithm is the one that sort of makes the prediction from the other predictions, kind of thing. You could say it's similar to the way a gradient boosted tree works, the way it takes the predictions and passes it along the chain, but that's the general idea. So, you know, a lot of people do have success with those, that you can balance the pros and cons of each algorithm. Now, I have seen write-ups about the strengths and weaknesses about stacking various different algorithms, and I'm sure it was on Kaggle, but, you know, there's probably plenty of blogs there that recommend, you know, for different sort of tasks like classification, regression, and whatnot, of some good starting points of what algorithms are the best to stack. But that's it. It's a trade-off. And of course, you know, usually the ones, you know, say if you have a gradient boosted tree and an SVM, yeah, their trade-offs might complement each other. But using an SVM and a gradient boosted tree, they're generally more computationally more expensive. So the trade-off is that it might take longer to get to them predictions. So yeah, I'd research it, what models complement each other, and hopefully, you know, you get a good starting point there. But yeah, the general rule is avoid similar architectures. But yeah, 90% of the time, using something that, you know, is the complete opposite will help. And it, you know, it's again, it's not a strict rule. It's experimentation. It's a bit of luck and a bit of black magic, if you want to call it that. But yeah, I'll see if I can find anything that I've read before. But yeah, that's good advice always. We've got less than a minute now. It's not giving me any sort of precise countdown, so I'll let you get back onto your Saturdays. Fantastic work, everyone. You're doing really well. Always very impressed with the dashboard, and Damir, very impressed with the experimentation. I'll see you